Um, so we have this problem of number complement. It's from Leetcode easy section, and this problem is based on bit manipulation. Now the question states that the complement of an integer is an integer you get when you flip all the zeros to one and ones to zero in binary. For example, we are given key if we are given 5, so the binary of 5 is 101. We need to convert all the ones to zeros, all the ones to zeros, and all the zeros to 1, and we need to return the output. So we'll be given 5 and we need to return 2. Let's take a different example. He will be given 7, let's say. Now the binary of 7 is 111. Now we need to convert all the ones to zeros, and we need to return the equivalent decimal representation, that is 0. So we'll be given 7 and we need to return 0. Now to solve this question, we need to know how to we need to know two concepts. One is XOR operand and another is left shift operation. Now let's write the truth table of XOR. So if we have 1 and 1 in XOR, we'll get 0. If we have 0 and 0 in XOR, we'll get 0. If we have 1 plus 0 or 0 plus 1, we'll get 1. Now why we will use XOR, you will get to understand. Let's say we have the initial bit to set to 0. Now if we take XOR with 1, now this is a hidden trial kind of thing. You can try with AND, we can try with OR, we can try with XOR, and we'll find it out कि कहाँ पे काम कर रहा. जैसे कि we given 0, we take XOR with 1, 0 and 1, we know कि 0 and 1, we take XOR and we get 1. So the initial bit 0 is flipped to 1. Now if our initial bit was 1 and we take XOR with 1, 1 and 1, 1 XOR 1 gives 0. So initial bit is again flipped to 0. Now you know कि हम XOR क्यों use कर रहे हैं. Now the left shift operation. Let's say we given 5. 5 is 101. What my logic would be key, first take 1 to the initial index and perform the XOR operation, and then move 1 from right side to the left side. Key we are at the rightmost side, so 1 XOR 1 will give us 0. Then move the 1 to the left by 1. 0 XOR 1 gives us 1. Again move the 1 to the 1 by 1 bit to the left side. 1 XOR 1 gives us 0. So this should be our output, and this is the value we need to output, return, right? So this is where the left shift operator comes with. Now left shift is like, if we say A left shift by B, it simply means that any integer A, the the binary equivalent, we will shift this binary equivalent by B unit. Let's say we had 101. Let's say we have 5 and we want to left shift 5 by 0. So it stays the same. We don't need to we are not actually shifting left by any value. Let's say if we say key 5 left shift by 1. Now 5, the binary of 5 is 101, and we need to left shift all the bits by 1, so it becomes 1010. One value, one empty space is occupied by 0. Let's take another example. We say 5 left shift by 1, so the binary equivalent of 5 is 101. Left shift by, let's say we left shift by 2, so we'll move this 2 times. So the other two vacant position will be occupied by 0, 10100. So you can clearly see it actually works. Now all we have to do is 101. This was our initial problem. We need to left shift 1 by first 0, so that 1 is here. Then we need to left shift 1 by 1. Then 1 will be here, 10. Then we need to left shift 1 by 2, so that 1 will be here, so that we can perform XOR each single time and store it in the original value. How do we do it? So there is one last problem. We need to know how many bits are there so that we can iterate over it. What if we had 100101? Now we need to know how many bits are there so that we can move 1 from the rightmost to the leftmost. Let's say we have here 1 2 3 4 5 6. Now we need to move 1 from 0 to 5. Now to do this, we can actually let's say we are given a number num. Now num is equals to 5. Do one thing, make a new variable temp and store it in the num, and every single time you run a loop. Basically you run a loop, a for loop or a while loop, where you check while temp is not equals to 0, we'll run this loop. Okay, now every single time you run this loop, decrement temp by temp is equals to temp divided by 2, and it actually works. Let's say 5, we had 5, we divide 5 by 2, 2 2s are 4 and 1. Again we take 2, 2 divided by 2 ones are 2, we have 0. Again we take 1, 1 divided by 2, we have 0. Finally we have 0. We perform this operation 3 times, so we will run this while loop 3 times. As we had 5, the binary of 5 is 101, we had 3 bits, so we'll run this operation 3 times, so that we can shift 1 from the right towards the left 3 times. Let's take a different approach. Let's take a different example. A big example would be 1000. Okay, 1001, 1001. Now this is equivalent to 819, right? 2 per 0, 1, 2, 3, 8. This is 9, right? Now take 9. What should be our goal? To left shift 1, 1, 2, 3, 4 times, right? Now how do we get this number 4? Do one thing, take the original number, store it in the value temp, and keep dividing it by 2 until you get 0, and that will be our number of time we will left shift 1 and perform the XOR operation. Let's say we had 9 and 2 3s are 8, 2 3s are 6, 2 4s are 8, 2 4s are 8 and 1 4, 2 2s are 2, 2 2s are 4, 1 2, 2 1s are 2 and 1, finally 1, 2 zeros are 0, 1. We perform this operation 4 times until we got 0. See, we will move 1 4 times and perform this OR operation, will actually get an answer. Now the basic, we'll get to the code later. Now the basic logic would be to run a for loop. Let's say for int I is equals to 0, and we had the num where we are given the question, let's say 5. Store it in a temp variable so that we can iterate over it. Temp is equals to num. We will run this loop for how much time? We can use a for loop or while loop or whatever we want. Temp, while temp is not equals to 0. While temp is not equals to 0, we'll increment I to I++. Now inside this, what we are going to do is, let's say we had the variable num. We will perform the XOR operation num. See, 101 will perform the XOR operation in the first index. Now how do we get I1 to be in the first index? Perform the XOR operation by shifting 1 in the 0th position. We shifted 1 to the 0th position, so we will get 0, and store this value in the variable num. And now we need to do num is equals to num divided by 2. That's it. This is our main code, and this will fetch us the answer. See, the next time we'll go, see, we have to store it in temp, right? We created a new variable temp so that we don't tamper with the num variable. See, the next time we will shift this 1 to the 1th position. The next time we will shift this 1 to the 2nd position. So we better put I over here. So first we are shifting 1 to the 0th position, then we shifting 1 to the 1st position, then we shifting 1 to the 2nd position, and we are performing XOR operation with our initial number and storing it in the number. The next operation will be 101 100 performing XOR with 10, right? One left shift of 1 will give us 10, one left shift of 0 will give us 1, one left shift of 2 will give us 100, and we'll perform XOR 1 0 and 1 gives us 1 0. Again we will perform a XOR operation 1 1 0 and performing XOR with 100. Now 100 performing XOR will give us 1 1 0 1 0, and the loop ends as temp becomes 0, and the loop ends, and we will return this variable. So this will be our answer. This is the code that I have written. Now getting into time complexity, this is our main code, right? And getting into time complexity, now this line I have written here is that what if our original value is 0? What if our original value is 0? Just simply will return 1. And for the rest code this will work. Now time complexity will depend on the number of number of bits. Let's say we have 5 101, so this will run O 3 times, right? What if we had 7 111, it will run O 3 times. What if we have something like 100 101? We need to check all these bits and change the values in it, so it will run 1 2 3 4 5 6 times, O 6 times. So the time complexity will depend upon the number of bits in the variable.